Okay, John, here's the deal with the U substitution. Okay, what we're going to do is let's say we want to integrate this guy right here. That's, I think, your confusion is why are they doing this substitution? So here's the deal. If I want to find an antiderivative for this guy on the inside, let me rewrite it over here so it's a little bit larger. So we've got 4 pi times the integral from 0 to 5 of x times the square root of 5 minus x squared over 5 dx. This is a calculus 1 topic, so you need to be able to do things by substitution. So here's the thing. You need to find, your goal is to find an antiderivative of x times the square root of 5 minus x squared over 5. You need to find a function that when you differentiate it, it gives you this. That's not easy to see. Okay? So I don't think off the top of your head, and this is what you should try. You tell me a function, f of x, figure out some function here, such that when I differentiate it, I get that. This is the guy you're looking for right here, okay? But it's really hard to find here. Okay, so what we have to do is a U substitution that makes it easier for us. So what we'll do is to find the U substitution, we're going to take part of this inside piece. I'm not exactly sure right away what I'm going to let U equal, but I'm going to try to let it equal something on the inside. Now here's where you have to play around with it a little bit. Okay, you're not always going to know what U should equal. So what I'll do is I'll let U be equal to the inside of the square root. So 5 minus x squared over 5. Okay, so I'm going to let U be equal to that. So what that does is, I'll write it over here, that makes me have the integral. Okay, I got the 4 pi, 0 to 5, okay, of x times the square root of U dx. Here's the problem though, you can't do an antiderivative when you've got different variables here like this. I need these to all become u's. I need this x to no longer be an x but to be a u, and I need this dx to no longer be dx but I need it to be du. Well, how am I going to replace this du? Well, what I'm going to do here is I know what du is. Okay, so du over dx is equal to the derivative of this guy. Well, the derivative of this, the derivative of 5 is 0. The derivative of this is negative 2x over 5, like that. Okay? Now, if I move some terms around, and this is not really mathematically legitimate the way that I'm doing this, but it works. Okay? I'm going to think about multiplying both sides of this by dx. Now the way that we've defined du dx, you really can't split them like this. But everyone does it, and the reason that you can do it is a nice just way of remembering how to get this. So these guys cancel, and I'm left with the following. I'm left with du is equal to negative 2x over 5 dx. Really, you can think about this in terms of your differentials. So in Cal 1, you cover differentials, and so you should be able to get this. So I want to replace dx. Well, dx is right here, so let's solve for it. So this is going to be 5 du over negative 2x is equal to, hang on, I lost my train of thought, is equal to dx. Okay, so I can now replace this. So this is equal to 4 pi, the integral 0 to 5 x square root of u times dx, which is this guy. Okay, like that. Now, what happens here is we said before I needed to get rid of this x. I need to make it into a u. Or get in terms of some kind of u. Or I just need to get rid of it, right? I can't have x's and u's floating around here. Only one variable. So this guy, this guy, look, that cancels with this guy down here. So what's left? Well, what's left over is 4 pi times the integral from 0 to 5 of the square root of u times 5 du divided by negative 2. And of course the 4 and the negative 2 cancel out. Okay, so this is going to give me negative 2 times pi times 5. We'll take this 5 and bring it out, just like we brought the 2 out as 1/2. Okay, 0 to 5 square root u du, like that. Okay, so let's keep going here. 5 times negative 2 is negative 10. Now I know they did their substitution with u being the backward part of this. It doesn't matter which way you do it. At least it shouldn't here. So 0 to 5 of the square root of u du. But here's the problem. We switched these bounds that we have here, this bound down here, and this bound down or up here are on the variable x. So x varies between 0 and 5. That's what we're doing. We're integrating from 0 to 5. But that's how x varies, not how u varies. So what we need to do is use 0 and 5 in this relationship over here. So here's what I'm going to do. I'm going to go ahead and I'm going to solve for x and figure out what u is going to be equal to. Okay? So if x was 0, u would be just 5. So if x equals 0 right here, then u would be 5. That implies that at the same time u is 5. So we're going to change our, this is going to be, oh, negative 10 pi. Sorry, I forgot the pi here. So this would be negative 10 pi. This is going to be a 5 down here. Now let's take the 5 and plug it in to here. So if x were 5, what would u be? Well, this would be 5 squared, which is 25. 25 divided by 5 is 5. 5 minus 5 is 0. So my upper bound is 0. So we're going to go from 5 to 0. Now this is kind of it's a weird way of writing it, okay? Because we're going from 5 back to the left. If you think about the integration here, 0 to 5, we're asking us to integrate this way. What you can do is if you get rid of this negative right here, you can flip these two guys their spots. Okay? But I'm just going to leave it. There's no problem with this, okay? It's just algebra here. So this will be square root u du. Now what I need to do is I need to find an antiderivative for square root of u. So what works its way backward? What when you take the square root of it gives you, or what when you differentiate gives you square root of u. So what this is u to the 1/2, which if we add 1 to the power, we use the reverse power rule here. So this is going to be u to the 1/2 plus 1 over 1/2 plus 1. And so that's going to be u to the 3/2 over 3/2, which is 2u to the 3/2 over 3. So this ugly guy is going to be negative 10 pi times 2u to the 3/2 over 3 evaluated between from 5 to 0. So let's go ahead and compute that. So that'll be negative 10 pi. Okay, times. First thing we do is plug in 0 for u. Okay, and so that'll give us 2 times 0 over 3, and then we subtract off when we plug in 5. And so that'll give me 5 to the 3 halves over 3, like that. So let's multiply this in. This will give us 10 pi, because the negative times, this is 0 by the way. This will give us a negative times a negative, positive, so 10 pi times 2 times 5 to the 3 halves over 3. And so this will give me, let's see here, it'll give me 20 pi, okay, 2 times 10 is 20. Now 5 to the 3rd power is 125, so the square root of 125 over 3, like that. And if we go back and we take a look, you'll notice here what I can pull out of the 125 to make it look like this guy, if I wanna reduce this a little bit, which if you put this answer in, it'll just tell you to reduce. This would be 20 pi. Of course, this is going to be 25 times 5, right? And you could have done this earlier, okay? So I'm well aware of that. So this is 20 pi times 5 square roots of 5 over 3, which is 100 pi times the square root of 5 over 3. Okay, this is your solution. But the important thing here is this right here, doing your U substitution. Okay, so if you haven't done U substitution before, or if you only kind of remember it from Cal 1, you need to go back and watch some videos. So what I would do is just go to YouTube. Okay. And let's type in integration by substitution. Look, there it is right there. And now there's a whole bunch of videos here that you can go ahead and watch where they discuss the U substitution method here. Okay, so you can go ahead and you can fast forward. Notice that they do the same thing here that I was doing, multiply by dx. Okay, differential formula. It all goes through the same thing. It's not just Khan Academy that's got these nice videos. There's all these other good videos out here that you can go ahead and watch. So we don't cover U substitution in this course because you're assumed to already have learned it. If you don't remember it, if you weren't taught it in your previous course, you need to go back through and review it.